Hi, hi, I'm Sabir again. So in this lecture, I'm going to discuss all about the symmetric and antisymmetric tensors. So what is symmetric and antisymmetric tensor? So I'm going to write down here. Uh, Symmetric and antisymmetric. So from the definition or from the title, you are pretty well known all about that. What is that? A tensor, for example, we say a tensor T, right? A tensor T is said to be symmetric if it is equal to its transpose, right? So if it is if any tensor T, for example T here, is equal to its transpose tensor, then it is called the symmetric. For example here, so T, so we write down in components, if we write down its components, then we ij, right, and its components is T transpose of T, something like that, ji, right? So tji is a transpose of tij, right? So if tij equal to tji, then it is called the symmetric tensor and have the property that is something. So if a tensor, say for example here, I'm going to give you an example here. Say t11, t12, t13, t21, t22, t23, t31, t32, t33. We have say here. So if this is the so consider this is the tensor, right? So if t1, that means ij is equal to this, right here, this part, and if t1 is equal to this 1 3, so this is the ij and this is the ji, right? Is t2 is equal to t2, then it is called symmetric. So say for example here, it already divides this way. So if these parts, these three portions and these three portions are equal to each other, then it is called the symmetric tensor. So that means it must have t21 equal to t12, right? Yeah. t31 is equal to t13. t32 should be t23, right? So this should be applied in case of symmetric tensor or something like that. On the other hand, what is the antisymmetric, something like that? If t ij is not equal to t ij is not equal to, sorry, I'm sorry for that. If t ij equal to minus tji, that means if t equal to minus transpose of its tensor, right? If this is this, then this tensor is said to be antisymmetric tensor and have the property something like, and have this kind of properties here. So that means here we can say here so in case of antisymmetric, it should be t12 equal to minus t21, right? Or t1 equal to minus t13. So this should have minus. Okay. So these are the symmetric and antisymmetric tensor, especially in many geodynamic or seismologic or in mechanical or any applied science problem. The symmetric and antisymmetric part has a great role, especially in rotation or in anti-rotation. Sometimes in geodynamic it is called spin vector, spin tensor, or something like that. In antisymmetric tensor is called sometimes spin tensor or rotation tensor. So in many ways you can explain this. So I'm going to teach you all about that in geodynamic or lithostatic deformation lectures. So any tensor T can always be decomposed into the sum of symmetric tensor and antisymmetric tensor. Say for example here, say if we have a tensor T, then it has a symmetric tensor and antisymmetric. So we can write down any tensor as a sum of the antisymmetric tensor and symmetric tensor. So this is a symmetric tensor and antisymmetric tensor, right? So if we sum this antisymmetric with this some symmetric tensor, then we'll get a tensor, right? So every tensor can be decomposed into two tensors, antisymmetric and symmetric, right? So what is symmetric tensor? Symmetric tensor is nothing but we can write down here t plus tensor transpose of T divided by 2. Then this is the symmetric tensor, right? And antisymmetric tensor, here T equal to T minus T to the power transpose equal to 2. This is the antisymmetric tensor. So if we write down this both of these, then we get T plus T to the power tensor divided by 2 plus T minus T to the power tensor divided by 2. Yeah, so this should be the T, right? Okay, I'm going to prove that. So this is the 2, so you can write down T plus T transpose plus T minus T transpose, right? So this T and this T transpose cancel out each other, then we will have 2T here, so we will have 2T and then 2, then we cross it out, cancel it out each other, then we'll have T, right? So T here and T here. So every tensor can be divided or can be decomposed into the sum of a symmetric or antisymmetric tensor. So in this way, it is not very difficult to prove this or something like that. So this is very easy, and we can use this application in many geodynamic or many engineering or many scientific applications. Yeah. So thank you, yeah, thank you for being stay with us, and I'm going to see you on next lecture. Thank you, and I'm going to I do apologize because my English is not very good, and because I'm not a native English speaker, I'm a Bangladeshi, so my mother tongue is Bangla, so I can uh, talk thoroughly in English as you must expect from me. So I'm so sorry for that, and I do apologize for that. Thank you, and I'm going to see you on next lecture.